How to find the domain and range of an even root function. The general form of even root function is f function of x equal to nth root g function of x. The n is even, e.g. 2, 4, 6, 8, etc. The domain rule of even function. Domain rule of even function. For even root, the expression inside the root must be non-negative. It means g function of x must be greater than or equal to 0. If g function of x is less than 0, the root is undefined in real numbers. Range rule for even root functions. The output range is always non-negative if there is no negative sign outside the root. If the function is like this, nth root g function of x. If the function is of the form function of x equal to minus n root g function of x, the range is non-positive. We want to find the domain and range of this fourth root function. This is fourth root, an example of an even root. It is only defined when the expression inside the root is non-negative for all real numbers. Now, for us to find the domain, let us set the expression inside greater than or equal to 0. X plus 5 is greater than or equal to 0. Let us add minus 5 to both sides. X plus 5 minus 5 greater than or equal to minus 5. So x is greater than or equal to minus 5 because plus 5 minus 5 will cancel each other out. So the function is defined for all x values greater than or equal to minus 5, and our domain is minus 5 comma infinity. We use square bracket here because 5 is inclusive. X is greater than or equal to minus 5. So that is the reason why we use square bracket here. Let us now find our range. Now we analyze what values function x can take, that is, the range. Let us plug in values of x that satisfy the domain. X minus 5 minus 4, 11, 91. Our function of x equal to 4th root x plus 5. If we insert minus 5 in place of x, we are going to have minus 5 plus 5, which is going to give us a 0. That means 4th root of a 0 is equal to a 0. If we substitute x is equal to minus 4, we are going to have minus 4 plus 5, which is going to give us 1. So 4th root of 1 is equal to 1. If we substitute x equal to 11 into this, we are going to have 11 plus 5, which is going to give us 16. 4th root of 16 is equal to 2. If we insert 91, we are going to have 96. And 4th root of 96 is approximately 3.1. And we can see as s increases beyond minus 5, the output also increases. The smallest output is when x equal to minus 5 and our function is a 0. There is no upper limit as s tends towards infinity. Our function also, 4th root of x plus 5 tends towards infinity. So our range is square root is 0, comma, infinity. We want to find the domain and the range of this 6th root function. Domain. Since it is an even root, the expression inside the root must be greater than or equal to a 0. So it follows that 2x plus 6 is greater than or equal to 0. Add minus 6 to both sides. We are going to have 2x plus 6 minus 6 is greater than or equal to minus 6. This cancels this. 2x is greater than or equal to minus 6. Divide both sides by 2. X is greater than or equal to minus 3. So the function is defined for all x greater than or equal to minus 3. So our domain is square bracket minus 3, comma, infinity. We use square brackets because our minus 3 is inclusive. Now let us find the range. Range. This is our function, but the root part, sixth root 2x plus 6 is always non-negative because 6 roots of non-negative numbers are also non-negative. Let us plug in some values of x that satisfy the domain. Minus 3 is part of our domain, 1 and also 2. If we substitute x equal to minus 3 here, we are going to have 2 multiplied by minus 3 plus 6, which is going to give us a 0. And sixth root of a 0, we are going to have a 0. And the function is going to give us a 0. Here also, if we substitute x is equal to 1, we are going to have 2 multiplied by 1 plus 6, which is going to give us 8. And sixth root of 8 is approximately 1.5. And the function is going to give us, because of this negative sign, it's going to give us minus 1.51. If we insert 2 into this expression, 2 times 2 is 4 plus 6, we are going to have 10. And sixth root of 10 is approximately 1.58. Because of our negative sign here, we are going to have minus 1.58. The maximum value is at x is equal to minus 3, and our function of minus 3 equal to 0. As x increases, the root grows slowly, but the negative sign turns it negative. So we can say as x tends to infinity, our function of x tends towards negative infinity. So our range is negative infinity, 0 square bracket, because our 0 is inclusive.